I'm Paul Rako, and this is the Atmel Edge, the show that makes you well-rounded and well-grounded. The show's for engineers, technicians, hobbyists, makers, anyone who wants to learn about system-level electronic design, embedded systems, and even mechanical engineers might enjoy it. Today we're lucky in that Henrik Flodell is with us. Your title, Henrik?
I'm the Tools Marketing Manager at Atmel.
Okay, and a tool is software tools, the development system, is that?
So the way that we define a tool really is anything that you use during your development process. So it's, the IDE is a tool, the compiler and the linker and all of that stuff that goes into it is also a tool. We also define the evaluation boards that we provide, the Explain Pro kits and the Explain mini boards, those are tools. And also the software that we provide in the Atmel software framework for you to base your applications on as part of the sort of tool platform that we provide.
Oh, great. Now, I first met you, was involved with the Atmel-ICE, this debugger that plugs in and helps people see what's going on inside the chip.
Yeah, that's correct.
And so the new Atmel-ICE, it works, what, with ARM?
So basically what we did with the Atmel-ICE was that we wanted to try to reduce the complexity for the developers when they are in the stage of the development stage of their projects, and they need to have debug connectivity with the microcontrollers that they're developing for. And we've had, an ecosystem basically of various debug probes and in-system programming devices for, the AVR cores that we have, the AVR32s, also the ARM devices. And we wanted to make sure that we had a probe that could cover the entire spectrum at a very low cost, that could do sort of basic run control debugging. So you can run your application, you can set your breakpoint, read back the data, and do some sort of limited tracing also on the parts that support it. So we went and looked at the JTAG-ICE 3, which was sort of the most recent probe that we released, and just added some initial ARM support into. And we expanded that to make sure that we covered the entire range of SAM MCUs, as well as ISP programming for the AVR devices, and combined everything into this Atmel-ICE. So it's kind of the one-stop shop solution for debugging on Atmel devices. So
it'll replace the Dragon, the old Dragon, and it'll replace this JTAG-ICE Mark III. There's still the AVR1. Is that used? Would that be used? A customer be interested in that for something?
So the Atmel-ICE does not have the streaming trace capabilities that the AVR1 has for the AVR32 parts. So it's not going to replace it. But for sort of basic debugging, yes, this is the probe that we recommend that people use.
And an AVR1 you wouldn't use on an ARM chip. That's it.
No, you wouldn't do that. And also the Dragon you mentioned. The Dragon is really sort of a little bit more than just a debugger. It can be used sort of as a low-cost debugger for some of the AVR parts, but it can also be used as a development board, right? Because it has this socket concept, so you can connect various AVR devices to it, and you can use it to do initial prototyping. Mm-hmm. We're coming out with a line of explained mini boards, we call them. These are really low-cost boards for low pin count devices that we think is going to, eventually surpass the Dragon in popularity when it comes to just getting access to cheap hardware for prototyping with the low pin count AVR devices.
Ah, great. I'd go back to a STK200, the in-circuit emulator.
Yes.
And I did a show where I explained, we're kind of sloppy about what's a debugger, what's an in-circuit emulator. What do you see, how would you explain the difference between an in-circuit emulator and a debugger in the strict sense of the word?
Well, sort of traditionally, if you go back a number of years, right, an in-circuit emulator was actually a big box that emulated the microcontroller core and also the peripherals that were connected to it. So it had a whole bunch of logic in there that made it possible for it to act as if it was a microchip. Today, we have debug logics in the microcontrollers that these probes communicate with, basically using standardized protocols. Some of these are, I say standardized, by that I mean across the different microprocessor families. There is a number of protocols that Atmel's devices use. Some of them are simple serial protocols that require only something like 2 pins to work. Some of them, like some of the ARM devices that we have, they use JTAG, which requires a couple more pins. But that's not an Atmel standard. It's actually an industry standard of the way that communicates. So the probe is basically it's a debug connectivity device that talks to the debug logic that's on the chip. So you no longer need to have this sort of big box emulating the hardware. You're talking directly to the hardware that you're using instead.
As it runs. And that's much better than people used to in Arduino. I guess you do, my friends say you do print F out the serial port. So you have to change your code to put a little flag in and say, right now, print out this register so I can figure out what happened. Whereas with the debugger, you're watching it work.
Yeah, that's right. It's called, what you're doing when you're on an Arduino platform like that is called instrumentation. So basically you're inserting messages. It's like, if you're developing on a PC and you want to find out, did I reach this statement? And you enter something like, got here, it
Right.
prints something on the screen to tell you that, yes, I ran past this address. That's basically what you're doing, but you're sending it out over a serial port instead. But with some of the devices, like for instance, the Cortex M3 and M4 devices that have, they have a thing that ARM calls SWV, Serial Wire Viewer. So this is a type of debug logic that is in the microcontroller core that allows you access to see what it's doing as it's doing it. You don't have to stop it to look at the status of it.
And that's in every single part we make, right? So when it's in your board, you can get these same signals out and look at it in a custom board that a customer designs?
It's, we have debug technology in all of the microcontrollers we make, but it depends on which architecture it is and sort of where it is on the performance spectrum for that family, exactly what features that we have in the cores. So on the AVR devices, we support certain type of debug features. On the SAM MCU devices, we support some other features, and it also depends there whether or not it's based on a Cortex M0 Plus core, an M3 core, an M4 core. There is, some difference. But going back to the Atmel-ICE, we've designed that in such a way that it can actually work with all of these features, irregardless of which microcontroller you're running on.
We're going to wrap up now. This is the Atmel Edge. I'm Paul Rako. This is Henrik Flodell. Thank you so much, and tune in next time.
All right. Thank you. Thanks, Paul.